Welcome to the next section of the Getting Started with Spring 5 course. And in this section, we're going to review the reactive streams. We'll take a look from the bird's eye view at all this reactive hype. Then we will take a look at primitives that are behind the reactive streams. And of course, in order to apply reactive approach to our applications, we need to understand how to process data in a reactive way. And of course, we need to bridge reactive vault with the blocking one. Okay, let's start from the bird's eye view on the reactive streams. Reactive is a modern paradigm for software engineering. Usually systems built with reactive approach have several key characteristics, like responsiveness in terms of providing the fast and responsive feedback to the user interactions. They are resilient to failures, resilient to load. It means that if failures occur, they handle them in gracefully and a more user-friendly way. They are also elastic to load and easy to scale. It means that if there is growing demand, they are easy to be scaled in order to successfully fulfill this demand. Usually, such systems built on message-driven architectures. It means that there is no any waiting or blocking approach, there is just exchange of messages between systems and within the system. So what about reactive programming? It's actually design of applications when we are dealing with routing and consumption of events. The ideas of reactive programming can be traced to the 1970s because it's not something new that's arrived just recently. There is just a growing demand for this type of architectures that can be related to the growing number of CPU cores and the data that should be processed in faster and scalable ways. As far as we know, Java is not a reactive language and does not support these concepts natively. There were several attempts to address this problem using external programming languages that are running on JVM like Scala or Clojure. Of course, version 9 of the Java is addressing this concept, introducing the reactive streams. As for the implementation of our reactive ideas within our applications based on Java, we can use several frameworks like reactive streams, which is actually a built-in implementation in upcoming Java 9. There is also RxJava, which can be used already right now in our applications, that is open source library provided by the Netflix. One more framework is the Reactor, which is implemented by the Pivotal, the creators of Spring Framework, which is following their reactive stream specifications. In order to provide HTTP-based reactive approach, we can use Redpack, which is a set of libraries to build high-performance services over HTTP. And there is one more library I would like to call, it is Akka. Akka is a toolkit for building applications using actor pattern in Scala and Java as well. As for the streams are the series of elements emitted over time. The series potentially has no beginning and no end. Contrast to that arrays, which are a series of elements arranged in memory, and arrays have beginning and an end. Streams are usually pool-based systems where data is pulled by the clients and not pushed by the producers. Usually streams are immutable, it means there is no changes on the data within the stream. And there are some operators provided by the streams in order to deal or process data within the streams like mapping, filters, reducers, etc. So what is actually the difference between streams and reactive streams? Reactive streams is a specification for library developers, which provides some specification and API for developers to be implemented, and business developers will leverage this API and some implementation and won't have to deal with some low-level concept. Reactive Stream started as an initiative in 2013 by engineers at Netflix, Pivotal, and TypeSafe. There is one more objective of Reactive Stream specification is to define the model for back pressure. Back pressure is actually the way to ensure that fast publisher doesn't overwhelm a slow subscriber. Back pressure provides resilience by ensuring that all participants of a stream-based system participate in the flow control to ensure that steady state of operation and graceful degradation.